4 years ago, I taught a robot to follow a line using OpenCV, and it was about time the robot learned to solve the maze on its own. No sensors, no cheating, just pure OpenCV and a bunch of if statements that I really do hope qualify as AI. Because really, giving sight to a robot, what could go wrong? So, how do you teach a robot to see a maze, understand it, and make decisions in real time with no sensors, no maps, and apparently no patience? Most maze solving robots rely on IR sensors, but just to make my life more miserable, I'm skipping those. Instead, I'll define 5 zones inside the camera's view and count the number of black pixels in those zones to differentiate between the black maze and the white floor. Bottom zone will keep the robot centered by making tiny left or right adjustments just like my old OpenCV robot. The side zones will detect if there is a left or right turn. The top zone will spot the intersections and dead ends. And the top right corner, that's our victory zone. It will detect the end of the maze. Now, all that sounded great until I realized the old Raspberry Pi Zero I used in my previous line follower robot has the processing power of a potato. So instead, I'm streaming the maze feed from my phone to my PC using an IP camera app. The computer does the heavy lifting, the OpenCV crunches the pixels and sends the command back to my robot over Bluetooth. Time to build the robot and write a basic test script just to see if the idea doesn't instantly fall apart. For some weird reason, this HC05 module on my robot was not receiving any serial data sent by my computer. I tried a bunch of other modules but none of them worked. Pretty sure the culprit is my computer's Bluetooth adapter. So now to send commands to my robot, I have to take the dreadful TCP communication path. It will transform my already slow stepper motor robot into a crawling turtle, but there's no other choice. I added a ESP controller to receive the TCP commands from my computer, which then forwards them to an Arduino to drive the stepper motors. Let's give it a go now. Somehow the robot missed the only available turn. I think the issue is with the zone thresholds. My room's lighting condition might be affecting the zone thresholds. Let me adjust the thresholds quickly and try again.
I see this as an absolute win.
Jokes apart, the robot was able to follow a straight path and make an accurate decision to turn. Still, there is one big problem. The robot is undershooting its turn, and I have some idea about what's causing this behavior. Let me explain. These little stepper motors are designed to move to a particular position that I command it to, but that movement is not consistent. You can see over time there is a shift in the final position. This can happen due to slipping of gears under load or small plays like this inside the motor. Now I can just throw money at the problem and buy good quality stepper motors or encoders. But that will just increase the overall budget of the project. And what's the fun in that? Instead, I'm going to torture myself to death by writing a self-recovery logic for the robot to tackle the over and undershooting problem. Finally, the recovery logic is working. After every turn, the robot will assume that it has undershot the turn, so it will start making smaller adjustments in the direction of the turn for 50 iterations until it finds a straight path. Else it concludes that its previous assumption was incorrect and it had overshot the turn instead, so it will start correcting itself in the opposite direction. I also went ahead and added the logic to find the shortest path for the robot to perform a speedrun. There were many bugs and I'll not list them here, but I was able to fix the critical ones, so everything is working as intended now. Let's hope nothing goes wrong. After many hours, many tweaks, and just enough pain to make it feel earned, it finally worked. Is it perfect? No. Is it over-engineered? Definitely. But does it solve a maze using computer vision? Heck yes, and that's more than I can say for most of us. Making this project was a huge undertaking. I may have made the slowest maze-solving robot that the mankind will ever see. The project files are available on my Instructables for anyone who wants to dive deeper. You can now support this channel by doing small donations and encourage my caffeine addiction. Lastly, like and subscribe if you want to see what ridiculous thing I overcomplicate next. Thanks for watching.